Okay, we're gonna continue up what we were talking about in class today. So this is 8.2, part 2, continuing with naming molecules. Please make sure you have your notebook out and that you are ready to write with the notes. Let's go. All right, with naming acids, acids are compounds that produce hydrogen ions in solution. So if we end up with this in a solution, that makes it an acid. There are two types of acids, binary acids and oxyacids. Remember, this was the vocab word that you wrote down from today. A binary acid contains hydrogen and one other element. So HCl would be a binary acid. The first word when you're naming binary acids has the prefix hydro, meaning hydrogen, and that's followed by the root of the element plus the suffix ix. So HCl we would call hydro, and then chlorine we would say chloric, and then we add the word acid. So the second word then is always acid. So HCl, hydro, because of the hydrogen, chloric, we add the IC ending, and then acid. Oxyacid, the other type of acid, is an acid that contains both a hydrogen atom and an oxyanion. So if you remember, oxyanions have at least one oxygen attached to another element. Okay. There's no lunch detention on Mondays. You'll have to come tomorrow. Okay, for naming this, the first word is the root of the oxyanion, and then if there's a per or a hypo in there, make sure you add that. Then, plus that, you're going to add ic if it ends in ate, or you're going to add ous if it ends in ite. So if it was chlorite, you would change it to chlorus. If it's chlorate, if it's chlorate, you will make it chloric. Okay? All right. Then the second word is going to be acid. Okay? So you can have hypochloric acid. All right. Here's just a quick little chart that shows you if the anion here, okay, was chlorate, which is ClO3. You're going to change the ATE to ic, and then you end up with chloric acid. Okay, the same thing here. So the H plus the chlorate makes chloric acid. Okay, the H here plus the nitrite, ITE gets changed to OUS, and you add the word acid. So now we have nitrous acid, HNO2. All right, so if for some reason this chart from 7.9 is not still real clear with you, make sure you get there, okay? All right, many compounds were discovered and given names long before the present naming system was developed. So for instance, water was around. It was called water before we had all these rules. Ammonia is another example, hydrazine, nitric oxide. So lots of things have more than one name. Okay, so an acid or other covalent compound can have a common name as well its compound name. Okay, and I want you to become familiar with both. Okay, so if we look here, we call water H2O is water. But if you look at the formula of it, it would be dihydrogen, the 2 hydrogens plus 1 oxide, so dihydrogen monoxide. Okay, ammonia would be nitrogen for the 1 N, tri-3-hydride. Some of the others, like aspirin, is 2-acetyloxy-benzoic acid. This has more to do with benzo rings, stuff we'll get into later. But just kind of be familiar with the fact that, for example, what we call hydrochloric acid can be called muriatic acid. You won't see this very often. Nowadays, almost everybody is going to call it hydrochloric. But just be familiar with that other names exist. But make sure that you know how to name these. Okay? All right. So here we go. Water, dihydrogen, 1 oxygen, monoxide. Dihydrogen. Oh, I didn't change the name here. So this should be dinitrogen. What should this be? Tetrahydride. Okay? All right. The name of a molecular compound reveals its composition, is important in communicating the nature of a compound. Basically, what this means is you need to know how to read and write in this type of nomenclature so that you can know what you're doing, but also let other people be able to reproduce your work. Okay, so that is all of this one for today. Make sure you come to class tomorrow ready to work on these problems. Make sure that you've also completed all 4 of your note cards for tomorrow. Remember that you need 2 that have the structures or the formulas, and you have 2 that have the names written out, and that they actually can work if you draw them out in Lewis dot structures. All right? Have a good night. I'll see you tomorrow.